Hello everyone, welcoming you all in the physics arena by Nitesh sir. Children, today in this video session, in this video lecture, we are going to discuss about the chapter that is the electricity, which is the most important chapter of your syllabus. So children, in this chapter, we will discuss about that. What do you mean by the household electricity? What do you mean by the household circuit? And what will be the electrical energy, electrical power consumption inside of the circuit, and we will also grab some basic concept regarding with the electric circuit. So children, first we are going to state about that is a household electricity. So children, what do you mean by the household electricity? Children, in our daily life we are consuming certain amount of energy. So how this energy comes to our house? Children, with the generation of the by the dams, we are producing certain amount of the energy in the form of electrical energy, and that energy is received by us with the certain channel. So the energy which we are going to use inside of our house is said to be that is a household electricity. It means that energy transmit from one place to the another place with the help of the power hubs. So children, in this chapter we will discuss about that what are the sources of energy. So children, as we are knowing that in our daily life, or what I am writing here, in our daily life, we are using certain amount of energy. So the resources that provides the amount of energy is known as that is source of energy. Means the source with which we can get certain amount of energy is said to be the source of energy. So children, in order to discuss about electricity, there are the two type of the energies are there. That is some of the sources which gives us the energy, that is cell or battery. Okay, so the cell or the battery provides us the current which remain constant with time. मीन्स हम कह सकते हैं कि एक हमें क्या मिलता है, दैट इज सेल इज ऑल्सो अ सोर्स ऑफ एनर्जी एंड बैटरी इज ऑल्सो अ सोर्स ऑफ एनर्जी. So there are the two examples has been listed over here that the cell and battery is also the two sources of energies. तो अब देखो बेटा सेल क्या होता है. अगर हम सेल को डिफाइन कर दें, in order to define the cell is nothing but the cell or battery. We can also define the battery in the same manner. Okay, the cell or battery. Okay, the cell or battery, here I am writing the cell or battery. Okay, the cell or battery is also a source of energy, that provides the current which remain constant. Means it is not going to be changed. Okay, which remains constant with respect to time. It means that the magnitude of current remain constant with respect to time. Okay children, with respect to time, it means that the value or the magnitude of current is remain unchanged with respect to time is called, that is a direct current, is called direct current. direct current. So children, it means that in our household circuit the two type of the current can be used, that is the direct current and the next one is the alternating current. It means that a current whose magnitude is constant with respect to time. In note we can write down that, in note what we can write, that a current whose magnitude is constant, whose magnitude is constant with respect to time is called direct current, and those sources are said to be the source of direct current. Okay children, so now we are going to discuss about what do you mean by the alternating current. Okay, so the main and the electric generator, we can say that the main and electric generator and that is the electricity which provides the electricity. The main and electric generator, provides us alternating current, which changes its magnitude and polarity, and direction, which changes its magnitude and direction with respect to time. Okay children, so we can say that AC current is a type of current which changes its magnitude and direction, with respect to time and surrounding. Okay children, so we have find out here the two sources of energy, that is the alternating current source and that is the direct current source, with which we can get certain amount of energy which we will use inside of our domestic power supply. So children, now we are moving towards the electric circuit, and where we will discuss about that the electric potential. So children, right now we are going to discuss about the topic, that is a potential difference. So children, as we are knowing that is a cell or a battery is having the two different terminals. One is known as cathode and one is known as anode, and both are having the different charges. So children, how we can define the potential difference for a cell or a battery? So children, potential difference can be defined as, right now we are learning the concept behind the potential difference. So potential difference can be defined as, right now we are going to define about the potential difference, can be defined as that is the amount of work done, in moving a unit charge, it means that the charge will be very small. So the amount of work done in moving a unit charge from one electrode to Another electrode is called that is what I have said here, that the work done in moving a unit positive test charge from one electrode to the another electrode is called potential difference. So children, it means that whatever be the amount of work to be done in order to shift a charge from one electrode to the another electrode in a circuit is said to be that is a potential difference between the two terminals. Okay children, and it is denoted by and the potential difference is denoted by the capital alphabet, that is V. So children, how we can give as the formula for the potential difference? So potential difference is represented by V, and which is equals to the amount of work done to bring a unit positive test charge. Okay children, so work done upon charge will be nothing but that is V is equals to W by Q, and it is known as the electric potential, or that is the potential difference. So children, if someone may ask with you that if Q is charge, W is the amount of the work done, then what will be the electric potential difference between the two terms, that is W by Q. If someone asks that if Q means charge, if Q means that is the charge is given, if charge is given and potential difference is also given, and potential difference is also given for a circuit children, means for a circuit, if electric potential is given, V is given and Q is given, then we can easily calculate, then work done can be calculated by the formula that W is equals to that is a V into Q, and that is V is nothing but that is a potential difference between the two electrode, that is a potential difference between two electrodes which is going to multiply with the unit positive test charge. So in this condition we can easily calculate that is a potential difference. Okay children. Now children, as we have learned that the power for a household circuit can be defined as that is nothing but that is a work done per unit of time, that is W by T. Children, as we are knowing that is a unit of energy. Okay children, unit of energy is joule, and for time that is in seconds. So joule per second will be also a unit of power, and also the unit of power can be given as in watts, that is in watt, that is a small unit. So watt or joule per second is the unit of the SI unit is joule per second, and watt is the unit. And children, in bigger we can say that is if we are willing to calculate 1 watt power of a system. 1 watt power means that 1 joule energy is going to be consumed for 1 second. If we say that if 1 joule of energy is going to be consumed for 1 second in an electric circuit, then it is said to be 1 watt power. And children, its bigger unit is, or also we can say that power is also given by that is P is equals to V into I. It means that we can say that if we are willing to define power in another word, then 1 watt power can be also written as, if this is a product of 1 volt to 1 ampere. So children, we can also define as, if 1 ampere of current is flowing through, the potential difference of 1 volt between the two terminals of a circuit is said to be the 1 watt power. Okay children, so right now we have discussed about that 1 watt power. Now the basic thing is that how this power generated is transmitted from one power generating system to the another. Children, there are the two different ways in which we can transmit the electricity. So here the transmission of the power from one power generation system to the another consumer. So children, the power which is generated at the power station is supplied to the consumers. So children, the electric power is generated at the power stations, and which is usually at a very far distance. So the electric power at the generating station, what I am saying, that at generating station means at the place where the power is getting generated. So at generating station, okay children, at generating station, the electric power is, right now we are discussing about how the power can be transmitted from one place to the another place. So what I am saying, that at generating station, the electric power at 11,000 volt, so that is 11 kV. Okay children, so the voltage generation has alternating frequency 50 hertz, and the voltage generated means whatever be the voltage is getting generated over there, voltage generated has a frequency 50 hertz. It means that it changes its vibration 50 times in 1 second children. Okay, sorry, that is 100 times that it becomes. Children, what we am saying, that as I am saying that at the generating station the electric power is at 11 kilovolt. Okay children, what does it mean? That it means that the voltage generated at the power station have the frequency of 50 hertz. It means that its polarity at the terminal changes 50, that is 100 times. Children, means in 1 second, once it is moves 50 hertz means particles vibrates 50 times up and 50 times down. This means of the 50 hertz frequency children. Okay, so as we are knowing that the alternating current is nothing but that is a type of current which changes its frequency or direction with respect to time. Okay, so the voltage of the power generation system is raised by, and now the voltage at power generation or power generating station is first increased by 11 kilovolt to 132 kilovolt children. Okay, in order to reduce energy loss, because in order to generate much more amount of the energy, we require a system which is having the less amount of the energy loss. That's why it is first converted into 11 kilovolt to 132 kilovolt, so that without the less amount of the heat dissipation, the power can be transmitted from one place to the another place, and in this way we can supply the power to a house. And so children, the domestic voltage, we can say that is a domestic voltage. Domestic voltage means the voltage which we are using, the voltage which we are using at our home is 220 volt. So this was the power. This right now we have discussed about that what do you mean by the household circuits, and what do you mean by the electrical energy, what do you mean by power, and how we can discuss that how the power transmission can take place. So children, power supply can be transmitted with the help of the wire, and so the wire is having the 3 terminals. Okay, so in the domestic circuit a wire is used, and with the help of that wire we are taking the power. So children, the cable has the 3 wires. Okay, means for the transmission of wire a cable is used which is having the 3 wires. That one is the live, that is phase, the neutral, and the earthing wire. Means we can say that for transmission of current or the energy produced, a wire is used, a set of wire is used, and having the 3 wires. The first one is phase wire, the first one is phase wire, then the second, it is also known as the live wire, then the second one is the neutral wire, and the third one is, children, that is earthing. It means that whenever excess amount of current, some excess amount of the current is flown through the circuit, that it can be grounded. So with the help of this arrangement we are going to transmit the power generated from the power station to the domestic houses. Okay children, so hopefully you all have got the point in which we have find out that how the power is generated and how it can be transmitted. Children, basically the phase wire is of red color or of brown color. Okay children, the wire, how we can find out the phase wire? Basically the phase wire is of red color or brown color. The neutral wire is of black color or light bluish in color, light blue in color, and the earthing wire is of either green color or of yellow color. So these are the colors with which we can easily distinguish what type of the wire is this. This is the phase wire, this is the neutral wire, and this is the earthing wire. So in this way we can easily calculate that what is the transmission of the power. So children, till here you have to learn, and after that we will discuss the subsequent topics. Have a great day.